Well, thank you so much for this wonderful introduction and for showing us how semiconductors are used and needed, and that this topic is actually one topic which is very close to our livelihood and our day-to-day business. Thank you very much for that. Dear ladies and gentlemen, thank you for being here. Thank you for discussing with us whether Europe can actually reshape global chip leadership. It's a very challenging question. And I'm delighted to have you here, gentlemen. Such a distinguished panel. It's truly great. Thank you that we are going to talk about this important issue in the next 35 minutes. It was a few years ago when the corona crisis hit that it really became obvious how much industries in Europe do actually rely on a reliable supply of semiconductors. And then the global shortage of semiconductors actually led to factory closures in all different kinds of sectors, from cars to healthcare devices. And also, it became clear that the demand for semiconductors would continue to rise significantly. It would even double in the year 2030. So to satisfy this demand and also to strengthen Europe's technical leadership, guess what? The European Chips Act was initiated. And with this Chips Act, the Commission hoped to also double the EU's global market share in the semiconductor industry from 10% then to 20% in 2030. This market is actually projected to hit $1 trillion by 2030, by the way, so it's really huge. And I think I'm not spilling any secrets that the goal the EU Commission has set out was very ambitious, and that it's maybe not really on track to reach it. So, Professor Kinneret, I'd like to start with you. You are, as we just heard, Executive Director of the EU's CHIPS Joint Undertaking. The CHIPS JU is a tripartite partnership of the EU Commission, EU member states, and industrial associates like ENAS or EPOS. And let me just get straight to the point. Today, the goal to double Europe's share in global semiconductor market does not seem to be reachable, at least in the next 5 years. What do you think has one overseen when the CHIPS Act was initiated?
Well, I think it's very easy, or relatively easy, to decide and predict what you are doing or what Europe is doing in this case. We don't really have control on what others are doing, be it the competitors in the East or in the West. So Europe is not operating in vacuum. So that was one thing that was maybe not predicted to the extent that it should have been. The other is that the timeline was very aggressive. These things take a lot of time and a lot of money. It's not a sprint, it's a marathon to do these things. We have some examples very well on the way, like ESMC, but you are not producing chips yet, I think. So it takes a while. So really the timeline is one thing, but obviously there was a discrepancy between the ambition and the means to reach the ambition.
Yeah. An important part of your work at CHIPS JU concerns the Chips for Europe initiative. So maybe you could tell us a bit more, what is the Chips for Europe initiative actually doing to facilitate the goal of 20% market share somehow in the foreseeable future, let's say.
Yeah, what we do can be divided into two parts. One is indeed the Chips for Europe initiative, which is focused on capacity building. So we are now building 5 pilot lines, which are not production facilities. They essentially serve the task to prove that something is manufacturable, something that has been developed in either industrial or academic laboratories in a small scale. It can be scaled up in principle so that it can be manufactured in large scale. So we have pilot lines in specific technologies like fully depleted silicon on insulator. We have pilot line on advanced packaging. We have a pilot line on advanced nodes, so sub 2 nanometer technology. One on wide bandgap materials catering towards, for instance, electric vehicle kind of things, and one on photonics. Another thing that we do is that if you can produce or manufacture chips, but you don't know how to design chips, you are in a bit of a limbo. The design abilities are absolutely crucial, so we are starting a design platform now, in general towards skills development and more broad support to companies. We have recently started 27 competence centers, 1 in each EU country. And then the last thing that is now in progress is more forward-looking activities focusing on quantum chip technologies. So what we do is capacity building, not really the actual production or manufacturing.
All right. Florent Ducrot, you are head of European operations. I hope this microphone is working. All right, excellent. At Applied Materials. And I think you're working for Applied Materials in leading positions since more than 20 years now, so you know the company very well. And Applied Materials is a US company.
Yes.
But you have a long-standing European presence for almost 50 years. So you are an important part of the ecosystem, and you actually have an interest in the ecosystem to thrive. So how do you see your role, let's say, in helping Europe stay and becoming even more competitive?
So, as you said, we always believed in Europe. You know, we are here since 1971. That was the first time we established. And we have actually across Europe more than 2,000 employees that are working actively every day to support the semiconductor ecosystem. We have done a lot of investment, working very closely with the R&D centers, but we also done investment where we just announced at the beginning of this week a technology center in Italy, where we are going to leverage our knowledge to train our employees, to train our customers, and ensuring that we make Europe competitive. There is in Europe a very strong ecosystem of R&D centers and customers, some of the customers that are actually number one in what they do. And we are obviously very happy to see that ESMC is coming here. We have a long-standing relationship with TSMC in Taiwan, and obviously working with new companies. So Europe is for us a very important piece of the semiconductor ecosystem globally, and we are committed to support this ecosystem.
Yeah, you just mentioned ESMC and TSMC, and you are president of ESMC in Dresden, Christian 𝐁𝐗. And before you became president of ESMC, you were actually CEO of Robert Bosch Semiconductor Manufacturing in Dresden as well. So ESMC is, you mentioned it, is a joint venture between TSMC, Infineon, Bosch, where you've worked before, and NXP. And you're not over almost 50 years here in Germany as Applied Materials, but it's like really new. You're building up a production plan. But how did the plan of this joint venture came up? And why did TSMC choose to invest in Europe, in Dresden?
I mean, we announced the formation of the joint venture in August 2023, roughly. And in order to answer your question, I can quote what our shareholders actually said at the point of announcement. There were a couple of arguments why the establishment of TSMC in Europe is a good idea. First of all, the EU itself said it is in our interest to establish advanced CMOS technology from TSMC here in Europe. That's why the EU CHIPS Act was actually the framework how we could do this investment. But our shareholders also said resilience of supply chain. This was a big topic from Bosch. Innovation, this co-location between chip design and chip manufacturing offers possibilities for innovations for our target sectors, industry, electronics, and automotive. And also, last but not least, by having another player in Dresden, additional to the already existing front ends, this makes the whole cluster even stronger. Scale effects are very important in our industry. And so the existing plants of Bosch, Infineon, and Dresden also benefit by having Florent being able to invest more in his capabilities in Dresden. And this is true for the whole supply chain.
Yeah. Yeah, you mentioned several topics I think we will touch upon later in the conversation again, like supply chain, like which strengths there are in Europe to build on. But before we do that, actually I would like to get you into the conversation, Daniel Schall. You are the CEO and founder of Black Semiconductor. And I know that Black Semiconductor is already very well known, but still, can you just very briefly tell us a bit about what your really fascinating technology does and where you stand in the process of planning, ramping up, actually production process?
The technology that we are building solves that AI scaling problem. AI applications need more and more compute performance. And if you continue to scale data centers like we do today, we build dramatically big data centers that consume much too much power. So you have to do something fundamental. You have to change something fundamentally so that this doesn't happen. And one of the biggest problems is the connectivity between chips so that they would act together as one large chips, even if they are spread out over many, many racks. Mm-hmm. And that problem is a communication problem, and you need light to solve that problem. And the reason is the distance and the speed between the chips or the speed of communication, the data transfer, and the distance, that's the problem. So you can communicate at a certain speed only so far, and then the signal is gone. That's what happens in a cable. And unfortunately, that distance is 2 millimeters. That's a problem. And it's very simple to see that if you have hundreds of chips or thousands of chips, that 2 millimeters doesn't solve the problem. And that's what firebursts do. And but now you have a problem that all of a sudden you have two different technologies. You have that optical technologies, which needs fibers, and you have electronics that needs copper wires. How do you bring that together in one unit? And that's what we do. So for the first time, we figured out a way, by the way, with a research program that Jari, 14 years ago, 2010, I think the first...
Started 2010,
yeah. The first steps did happen in 2010 with graphene, one layer of carbon atoms. It turned out that material can do that optical transition in a regular computer chip without changing the computer chip. And that's the magic. You leave the CMOS, the electronics alone, and add the photonic functionality on top. And that's why we can contribute to solving that AI scaling problem.
And your company is, I think, one of the companies the EU Commission has thought about they would like to have in Europe, I suppose. I mean, you were founded in 2020, so it was before the CHIPS Act. was actually initiated, but still. Why did you choose to found your company in Aachen, of all places?
Oh, we had a lot of discussion where to do that. Do we go to Dresden, or do we go to France, or do we stay in Aachen? We chose to stay in Aachen because of the proximity to the environment in Ghent, Leuven, Nijmegen. So IMEC is around the corner. Because we ask ourselves, what's our biggest problem? Is it the engineers and the machines, or is it on the understanding the material and the design? And we chose for material and design and say, okay, with the help of fantastic support of AMAT, we get that engineering problem under control. And we considered that this was the priorities we had. So we said, okay, let's go first for smart people that know how to work with the material and can do photonic design, and that's a very good spot is in Aachen.
So this sounds actually all very good, doesn't it? I mean, great infrastructure, great people, great environment. So I'm just wondering, why are we still not there where we want to be? So I think maybe we start to talk about some of the pressing issues, and I think, like in almost every industry, the shortage of skilled personnel is a huge issue, also in the semiconductor industry. And I'm just going to ask it very blunt. How can we address the critical shortage of semiconductor engineering talent? Christian Koch, you have any thoughts on that?
I mean, when ESMC is fully ramped, we will have 2,000 associates working in the company itself. At the moment, we are 50, so there's a long way to go. Yeah, so I'm with you. This is a big challenge, but we are well prepared and we started early. TU Dresden is our local university in Dresden. We have an internship program with them that we established at the beginning of 2024. And this is a program where I personally think I want to be young again. You know, I studied in the States. I had to organize everything myself, scholarship, where to study. Now we have these programs where young students, they are being sent to Taiwan. They spend 4 months in a Taiwan university, then 2 months in a fab of TSMC to learn the trades. And this we will continue for the next years in order to build up that pipeline. But also, beside the academic talents, don't underestimate, you need a lot of people with very skilled golden hands, so to speak, because the equipment is good, but it's complicated. Yeah? So you have to maintain, you have to repair. So we also invest in vocational training. Our fab will be ramping in 2027, but we already start this year so that we have the first technicians up and running when the fab is ramping. So don't underestimate the topic, but everybody has to do his homework.
Yeah. Florent Ducrot, has the Commission maybe, when they initiated the CHIPS Act, has the Commission focused too much on fabrication and forgot a bit about the personnel?
Yeah, so I'd like to elevate a little bit just to frame the problem that we are after when we come talk about talent. You know, as you said earlier, this is a market that is forecasted to be $1 trillion by 2030. Today, if we look around the world, there is about 2 million employees working within the semiconductor ecosystem. And in order to go to the 30 billion, we're probably going to need another 1 million of talented people across the world. Now, how do we make Europe differentiated and being able to attract talent? The pool of people that we are looking at is no longer German for Germany and France but it's actually much bigger. In applied materials, actually, in the office like in Dresden, we now have more than 30 nationalities, different nationalities of people that we attracted all around the world to come to work for us. Now, once we have identified the talent, we have to train the talent, and the most complicated is to retain the talent. There is obviously growth in the Dresden area, in the Grenoble area, and everybody is actually fishing in the same pond. So after that, it's about the strategy that each companies are putting together to be able to value the employee, continuously train and give opportunities to grow within the company and be able to be satisfied with the work that we are doing. We are doing also a lot of partnership with university, and we are trying to communicate to those universities the curriculum that we would need students to start following. There is a big change what we get out of the school directly and what we need, specifically when we move to a very advanced fab. There is a certain knowledge that are needed. So we try to communicate and work with the university to do that. And as I was saying earlier, you know, we are developing our own training center in Italy where we are able to bring the talented and continuously, you know, develop where they are. Last things I would like to say, it's about mobility. I think that if there is something that we need to work on with the European Commission is how to make the mobility of the people easy. You know, coming outside of Europe to Europe, or actually within exchanging resources across Europe, is definitely something that has to have focus. We had the opportunity actually to sit down with the EC members in Brussels and explain them that moving forward, it's going to be very important to have around that table the industrial companies, the OEM company, the academia, as well as the R&D and the legislation people, to all together agree on what we should do differently to bring and retain the talent in Europe.
What do you think, Daniel Schall? What needs to happen to get more talent into the industry and into universities first, maybe?
First of all, I just interestingly learned that Black Semiconductor is bigger than ESMC. At least today. We are 100 people, and they come from academia, but they come also from all around the world. They come from Malaysia, Singapore, Taiwan, US, Canada, and all over Europe. They sell their houses in the US and come to Aachen.
Wow.
Okay?
That's amazing.
And same Singapore, Taiwan, and so on. It's really crazy. And they do that because they like the idea of a fundamental change. How often do you have the chance to fundamentally contribute to a change, a step change? And that's why they come. Of course, hiring 100 people is one thing, hiring 2,000 people is a different exercise. We don't need 2,000 people, we need a few hundred, so I think that's why it will work.
There is another topic I would like to touch upon, and I know it's a bit sensitive, but still, it's investment. I mean, the European Union has put forward the number of 43 billion up until 2030, where the Commission is giving some money, some part, where the member states, of course, are expected to pay their share. And of course, it's a lot, but still, compared to other regions, it's not that much. So I'm just wondering, and Daniel, I just know that you happen to secure a very large funding, so I'm going to ask you that question. So
yes.
Nobody thinks you are complaining. Is public funding commitment in Europe sufficient, and can it overcome the higher operational costs we have here?
I think Black Semiconductor, we are a very nice example of how things should go. Because it is a European story from A to Z. It's a European material discovered in Europe, researched in Europe with a long-term program that enabled all this research over the years. And then we had the opportunity to start a company, and just the right moment that 𝐵𝐶, Important Project of Common European Interest, was created, so before the CHIPS Act, and we applied because we said, here's the idea. We want to transform a lab-level demonstration. We have lab demonstrators, not only we, a lot of institutes in the world have shown that it's possible. So here's the lab-level demonstration. Next thing we have to do is an industrialization. But that costs money. We get private investors, but we need help. Would you do that? And they said yes. And I think we should do that more often. There should be more attempts like Black Semiconductor. Over time, that will have a huge impact. The growth of the economy in the world is driven by very few companies. There's 100 companies that drive the entire growth. So a few companies can make the difference. And if you have 10 shots, chances are good that one of them survives. And that should be the attitude here. Not so much be afraid about, okay, we might waste a lot of money, but what's the upside?
Mm. Anyone wants to add on that? Yeah, please.
I would like to add something because there's one aspect of the European Chips Act which was a very good idea and it really helps us. And this is the fact that in the European Chips Act it is stated chip projects should be accelerated as much as possible within the regulatory framework. And this really helped in the member state regulations on federal level, on state level, on local level. This gives us speed. But of course, this is not over. Yeah? So when we go forward, I think we should really look at what is necessary in terms of regulation, what can be lifted in order to get more speed and more time to market. This would be a request to the European Union to continue that way.
Yeah. The Commissioner Séjourné has yesterday published his new strategy for the single market. Would that be a helpful step as well for the industry, or?
I have to tell you, I have not looked at it yet. It was yesterday, so please.
All right, no, that's fine. That's fine. I tried to get you talk a bit about some problems, which there are, obviously. But on the other hand, of course, there are strengths as well. And maybe I can quote you something which the German industries, the Federation of German Industries, just said in a recent strategy paper, because they said, okay, on the one hand, due to the division of labor in the semiconductor production, complete independence is not realistic. We can't reach that, but instead, and I'm going to quote that, Europe should secure an indispensable place in the value chain in the sense of strategic indispensability through unique high-end products. What is your response to that, 𝐵𝐼𝐴?
Yeah, I had not heard that before, but I have made similar statements myself before that. We are not trying to become independent of the rest of the world. We just want to make sure that the rest of the world is also dependent on us. Mm-hmm. And of course, there is one most shining example of that, ASML, that not a single foundry in the world would work without equipment from them. So yes, we are necessary for everybody. But to quote a representative of the Dutch funding agency, ASML is not enough. We need BSML, CSML, and DSML to make sure that there are more of these ground jewels of our industry. And that's maybe Daniel is working on one of them, but we need to indeed make sure that there will be several of them. And most of the innovative ideas come from small companies, often as a result of long-term research activity. And then we need to create opportunities that the companies can grow. And there, at some point, we start talking about money, for instance. And it's everything needs to work. Employment conditions and so on must be such that it is profitable to do business in Europe.
Florent Ducrot, where do you see Europe's strength?
If I look at Europe in the face of strengths, our research and development, we have a network across Europe that is actually very diversified with a specialty, depending with whom you work for, you know, IMEC and Leti of Hanover Institute. They all have very strong differentiation in their capabilities and the product that they are developing. I think there is a program that lately has been published called FAME that is actually bringing the entire R&D ecosystem together to share knowledge, information, and make product available faster. Faster because we need to be first on the market to compete against the other region in the world that are actually moving very fast. So that's one strength. The second strength that I see is we have customers, as I mentioned earlier, that are number one in what they do. Infineon, Bosch, NXP, ST, and now we are lucky to have TSMC, ESMC with us in Europe, and Future Black, where all of those companies has got very highly differentiated product, and they are contributing to the global ecosystem. They are not just known in Europe. So now the question is, how are we going to leverage these strengths that we have, accelerate the development of product with the research and development, as well as leveraging company like Applied Materials, so you mentioned also ASML, so that we can support our customer to be first to market, obviously be competitive, and if they are competitive, they will be able to attract more customer, and if they attract more customer, they will invest more, and suddenly it's a positive spiral for Europe. So we are all looking to pull Europe and be a key, even bigger player into the market moving forward.
Yeah, listening to you and thinking about what you are actually doing, I'm wondering, is ESMC one step in the direction to secure a stable supply chain for the industry, thinking of future crises ahead?
We are doing our level best every day. I mean, at the moment, it's a huge construction site. If you drive on the Autobahn towards Dresden, it's hard to miss. Yeah, you have 14 tower cranes, and we have poured the first base plate, so we are good on our way to ramp the factory starting in 2027. And this will be an important corner piece of the European manufacturing capacity, and in that sense will add resilience, yeah, for sure.
Compared to 5 years ago, when the Corona crisis hit, you mentioned in the beginning, where do we stand in terms of security of the supply chain? What do you think?
Well, the interest of what happened 5 years ago, it's actually brought to surface, something that maybe nobody was actually really paying attention to, and brought the need for Europe to be less dependent on the rest of the world, right? So growing the supply chain in Europe is a need and is a must moving forward. We talked a lot about being more dependent on our defense and on AI and on electrical or autonomous vehicle, which are big inflection for the semiconductor industry, and Europe is going to actively contribute to that. So the supply chain of chips, the supply chain of parts, the supply chain of system, the people is definitely something that has the highest importance, and I think we are on the right way right now. If you look at semiconductor 5 years ago or even before, it was not so popular on media, on TV, and people was not so much talking about it. It's becoming a topic at the country level. Each president in Europe are talking about being an active part of the semiconductor, and I think it's all good for what we are trying to achieve in Europe.
That's a great and interesting prospect, and what it's still to come. Thank you. We have a bit more than 1 minute left on the panel, and instead of me wrapping up what you just said, I would like to ask each and every one of you the same question, and to make this even more challenging, I would ask you please to answer in one sentence so that we still will stay in time. I will start with you, Daniel. What is essential to do now so that Europe has a realistic chance to reach its goal of 20% share of the semiconductor market, maybe in 2035?
Build great products.
Excellent.
Thank you very much. Christian 𝐁𝐗, what's your take?
Continue in its path, do your homework.
Florent Ducrot?
Work together in one team, we are stronger.
Excellent. And 𝐤𝐈𝐓𝐄𝐗, you may wrap it up.
Collaborate.
Excellent. You're wonderful. I thank you very much for your insights, your thoughts, and your time. Daniel Schall, Christian 𝐁𝐞, J.I. Kinneret, and Florent Ducrot. Thank you very much. And thank you, dear ladies and gentlemen, for your interest in this important topic. You're a great audience, and I hope we are going to have another great panel and more interesting and fruitful discussions here at the fair. Thank you very much.
Thank you.